Hello, everyone. It's great to be here. Just a few years ago, building conversational apps was a real task. You had to get your users to read reams of pages, and then take that and build complex statistical models, and then manually tune them over many months before you got to a point where it could hold a conversation with the end user. Today, with a few simple imports of easy-to-use libraries, you can build conversational apps which understand everything that you say, your dreams and aspirations, your fears and follies, and be your faithful companion, right? Turns out not quite. There is a ton of data, both natural language and speech, that's available, and neural networks have never been more capable. However, with that power, there's also greater expectations. Your users are prone to turn off and abandon your application if those expectations are not met. I'm Karthik Halakurike, the technical lead on Team Autopilot. And over the last several months, we've been thinking about the various use cases that really matter to users and cut through the science fiction and kind of build the features that really matter and solve customer issues. At the same time, me and my wife have been working hard on getting this guy ready for the world, and he arrived today. I feel like I deserve a reward of some kind. It's a pretty great coincidence, and I intend to write to, I guess, HR and maybe get a bonus or something. But, well, poopy diapers and sleepless nights are reward enough, I guess. So to build Autopilot, we have to really think about what really matters, like I've been saying, to the users, and then try to distill it down from all the research and all the hype that you hear, and build a repeatable process within the team to get it out to you guys. So imagine you're tasked with building a natural language application, an application that accepts natural language, and that it does a couple of basic things. It does entity extraction and sentence classification. So you put together an NLP pipeline, which does some of this, and you slap together a binary classifier to classify sentences into a small set of classes. Let's see what that means. Entity extraction, just to introduce these concepts, is the process of extracting useful information from what's been said on your channel, either voice, text, or in the future, GIFs and emojis even. So you're trying to extract nouns and verbs and adjectives in the language of the conversation. And alongside that, you want to be able to get the gist of what is being said, so you can respond in kind. So to do that, you train your machine learning algorithm. You give it some examples of what those classes look like, and you assign tags to them. And it would look something like this. You're building a coffee shop app that serves people coffee in natural language, and If the user is saying something like, I need a large coffee, you want it to tell you that the user intends to order an item of some kind. And they're trying to check the order status and so on. So to build a classifier, a basic building block is what's called a word embedding. Machine learning algorithms and neural networks in general work with numbers, and you want to be able to encode either text or images or whatever you're working with into numbers. For text especially, the way this is typically done is to create what's called a word embedding. It's a way to organize text. One way to do that is to just assign a random integer along a wide array and use that array and pass it in as the input to the machine learning algorithm. So abbreviations in this example has that representation. Or this is a pretty brute force way of representing text. You could also do it more intelligently and build some more context into the embedding by saying, by placing the text in a hyperspace in such a way that the words that have similar word counts are placed together, or if in a sentence words tend to occur together, you place them together in hyperspace and take those coordinates, and that would be your numerical representation. Now, you're building this app and you use the one-hot encoding method, which is a simple, easy to use way to do this. As an engineer, this is easy to implement, and you go ahead and do that. And you test this out, and you see that if someone says, I need to buy an Apple laptop, you've trained your classifier to say, to recognize things like buy an Apple is mapped to something like Apple purchase. And then buy a laptop is mapped to something like laptop purchase. But since you're using brute force one-hot encoding, Apple and laptop have no relation whatsoever. So your classifier would struggle to really make sense of this. So you go out and you look for solutions to this. There are some. We discussed how you could use co-occurrences if you want to say, I want to build an Apple, I want to buy an Apple laptop. Since Apple and laptop occur together, you can encode them to mean to have similar numerical representations, which is a signal to the machine learning algorithm to treat them similarly. Or there are other approaches, continuous bag of words, skipgrams. We don't have to go into that. But then your task now is to choose the best one amongst these. So as a good engineer, you think of this as an engineering problem, and you build an experimentation framework, a framework that shadows the same end user data or test data through your systems, keeping everything the same except the piece that you want to experiment with, in this case the embedding. Everything that the user is saying would still go through a production model, but then you have results of how other embeddings would look like. At the end of this, you've picked the best embedding for that use case, and you go enjoy your happy hour. Guess 3 drinks down, you get paged, and you realize that some of your hosts are running hot on memory. It turns out that the embedding that you chose is really large, and somehow you didn't do your due diligence. So you put down your drink, get back in, and you think about this. And we've looked at how embeddings are pretty much similar to a key value map, and they can be treated as such. So you put together Redis key value store, and then hack your code to not load the whole embedding into memory, but just serve the right vector, the numerical representation for the given word as needed. Another solution in your belt, and you go back for last call. And then you get in on Monday, suppose, and you're adding more features to your application, and this requires that you add more and more classes to your classifier. The simple binary classifier that you built earlier just does not do the job, because if you have the more number of classes you have, the operation that you see here is to be repeated for all those classes. And there are ways to do this. You either compare each class against every other class, or each class against all the rest of the classes, and so on. There are optimizations, but they are CPU intensive. And now you are running hot on CPU. So you do more experiments, but now you build that repeatable process. You go from bootstrapping to thinking about experiments, building that experimental framework, and you can now scale your system by repeating experiments on that framework. So you read various research papers, blogs, and technical articles, and you realize, okay, there are about 3 other classifiers that might do the job. A neural network here, a statistical model there. And you still want to validate which one works best, run it through the same system. Now, once you have that, now it's time to go the next step and think about what it means to serve different use cases. You're serving, your application was able to react to, I want to buy an apple, and now maybe your product manager wants you to sell laptops as well. Some of these classes might require a ton of samples, although the number of classes themselves are few. But then other use cases might demand hundreds of classes, even though the number of samples in them are pretty small. So you go and invest in something like a neural architectural search to find a model in real time. But then remember, you already have an experimental framework which promises to find you the best solution along the way. You were using this in test mode, but now you could expand this to find the right model in real time for the particular use case. So with this repeatable process, we've been able to take ideas from the field. We've run several hackathons with customers around the world. Some of you might have attended some of it, and taken your feedback, the use cases that really matter to you, the kind of research work that's out there, and really iterate on it quickly to bring autopilot. So you could do all of this. You could build the same experiments. You could run the same experiments and build your app. Or you could use autopilot. We've been, there's a lot more to this, and we look forward to hearing from you, your feedback, your use cases. Try it out, give it a shot. We'll be at the booth all day tomorrow. Look forward to talking to you folks. Thank you.